Hello everyone, my name is Flavia. I manage the bioimaging unit here at Oxford Brookes University. The bioimaging unit is where we have our light and electron microscopes that we use to image a variety of biological materials. Biological imaging has always been a very strong aspect of the research done here at Oxford Brookes, so you will see that the bioimaging unit here is very well furnished with a wide variety of microscopes and microscopy equipment. I am mostly in charge of the electron microscopy side of the bioimaging unit. My colleague Joe McKenna is in charge of the light microscopy side of the unit.
Hi, I'm Joe McKenna. I'm a research fellow in the department and I look after the light microscopes here at Oxford Brookes.
The bioimaging unit is housed in the Sinclair Annex, which is a modern building right behind me here. This building only opened a few years ago and it was purpose-built to house research labs and microscopes. This here is the ground floor of the Sinclair Annex building. This is where the bioimaging unit is. The bioimaging unit practically takes over the whole ground floor of the Sinclair Annex building. Most of the rooms here on the ground floor have microscopes inside of them. A lot of the rooms that don't have microscopes inside have equipment used to prepare samples for microscopy.
So within Oxford Brookes Bioimaging, we're really lucky that we have a number of really high quality light microscopes. And this is recognised by the fact that we're a Zeiss Labs at Location partners. That means Zeiss, the big microscope manufacturer, they bring people here to demo their microscopes at our facility. So we've got a number of different types of light microscopes. We've got wide field systems, so these are fluorescent systems with very high sensitive cameras. These are fantastic. We're looking at very nice thin flat samples, so that mammalian cells in cell culture, or such as trypanosomes that are fixed. And we've also got a number of different confocal microscopes. The confocal microscopes are very clever, because what they allow us to do is they allow us to get a really high signal to noise ratio, so a very high resolution of image. And the way they do that is they've got a very clever system inside which basically blocks all of the out of focus light. So what you're seeing here is some images of the plant cytoskeleton. You can see microtubules, and you can see axin cytoskeleton, and also we can see the plant endoplasmic reticulum as well. The other great things that confocals are really good for is for doing 3D images. So they can scan through 3D sections, they can section each part of a sample, and they can scan through, allowing you to generate really high resolution 3D data. This behind me is the big microscope. This is the Zeiss LSM880. This microscope is absolutely fantastic. Its scan speed is really fast, and it's equipped to do something called super resolution imaging with an airy scan based approach. The images that you're seeing now are from plant plasma membranes, and these are nanodomains that are only visible with super resolution techniques. They are not visible with normal confocal microscopy. And the example you're seeing now is a plant endoplasmic reticulum, which is being imaged very quickly with the airy scan fast system, and you can see you have a really fantastic image. The other confocal microscope we have here at Oxford Brookes Bioimaging is the Zeiss LSM800. Now the best way to think of this microscope is if the 880, which we saw previously, was like a Ferrari, this is like a BMW 5 Series, really trusty, reliable microscope. This is also an upright microscope, which means that the lens is coming down onto the sample, which is flat here. What this allows us to do is to use things such as water dipping lenses or micro manipulators so that we can apply mechanical pressure to samples and monitor how they do. This system is also equipped with airy scan super resolution imaging and can do most of the things which the LSM880 can do.
There are times in research when you would need to see details inside cells and tissues that are so small that you cannot resolve them by light microscopy. In that case, you need to do electron microscopy. Here at Oxford Brookes we have 3 different electron microscopes and a lot of electron microscopy sample preparation equipment. and you can do a huge variety of different electron microscopy techniques here at Brooks. This microscope next to me here is our transmission electron microscope. It's quite a new microscope, this one. It only came to Brooks last year. This microscope allows you to look at very, very thin slices of cells and tissues so that you can see all of the cellular ultrastructure in very, very tiny details. It also allows you to look at small things like viral particles and extracellular vesicles. With this particular microscope, you can also do a technique called electron microscopy tomography. This is when you look at a slightly thicker slice of a cell and you image it at different angles so that you can make a 3D volume of this slice of cell. Then with this 3D volume, you have exquisite resolution through this region of the cell. This here is our conventional scanning electron microscope. This microscope is really easy to use, really user-friendly, but at the same time it produces beautiful pictures of the surface of biological materials. Here with this microscope you can image, for example, a whole insect. Looking at all the details of the surface of the insect, you can image whole plant surfaces. So it's a really nice, powerful instrument, but also very easy to use. This microscope behind me here is the fanciest electron microscope that we've got here at Oxford Brookes. It's called the Zeiss Merlin. The Merlin is a special type of electron microscope. You don't find this type of microscope everywhere, so it's quite a treat to have one of those here at Oxford Brookes. With the Merlin, you can look at hundreds of consecutive slices, very thin slices, through a small piece of tissue, and at the same time look at the very small details of the cellular structure inside this tissue, and then do 3D reconstruction of organelles and host cells and whole bits of tissue with electron microscopy resolution.